Okay, this question is an application question for differentiation. So it says that a dynamite blast blow a heavy rock straight up with a launch velocity of 160 feet per second, about of 109 mph, which means that it's a mile per hour. So this means that the dynamite here blow this heavy rock right here vertically straight up, going upwards, okay, with the speed, that is a initial speed right here, which is the 160 feet per second. Okay, so means that this initial velocity going upwards for this rock is 160 feet per second. So then it says it reaches a height of s is equal to 160t minus 60t squared feet. So this one, we understand that it's feet means that it's a movement, okay, or a displacement. S is actually the displacement. These full equations actually means that it's the displacement of the rock, of the object, moving object. So after t seconds, so which means that the traveling path going upwards, as you can see from the diagram itself, the arrows, the rock going upwards, okay, then it will reach the peak point, then eventually then it will drop, come back down again, right? And finally you see go up, okay, go up, and then it will come down, right? It will come down and finally come back to the ground. So this s is equal to 160t minus 16t squared actually express the full traveling path, okay, from the ground going up to the maximum and come back down to the ground, the true full traveling path. Okay, so that means that actually I know that at this ground level, the s is actually at 0, okay? S is equal to 0 when it's at the initial positions, okay? So initially, of course, there is no displacement, right? The rock is at the original place, so S is equal to 0, okay? So this is information that I know. And then the S, the displacement of the rock will keep increasing and increasing until it will reach the maximum height, right? So I can label here as a S maximum here, S maximum, the maximum traveling path, okay? And then of course it will come back down again lah, okay, come back down again and reach back the ground, yeah. So basically this information is given, okay, and we can actually draw out the diagram in order to help our understanding on these application questions. And of course in this question there is hidden information. So as we understand the characteristic of this free fall or the motion of the object that is going up vertically and come back down to the ground, yeah. So when it reach a maximum, so we understand that the rock itself will stop for a short while here at the maximum point right here, which means that stop for a short while means that there is no velocity, okay, no velocity. So means that v is equal to 0 at this level, okay. So at this level here, the v is equal to 0. So this is the hidden information, so we need to label it into our diagram. Okay, so once we have done labeling our diagram, then of course then we can start to find out the answers for each of these questions right here. So we start off with the question A. So question A asks that how high does the rock goes? So the rocks of course will go to the S maximum. So we want to find out the S maximum actually. So X maximum at that level, okay, we have this information that we just interpret it out, okay, which V is equal to 0. So meaning that in order to answer for question A, okay, so we start with this information given V is equal to 0. So we know that we have V and V is equal to 0. Okay, and in the question itself, you will realize that another information that we have is actually the S equation. S is equal to 160t minus 16t squared, okay? So this is information. So we understand that if we differentiate the S, differentiate the displacement, if we perform a differentiation, we know differentiate the displacement ds over dt, it means that we are obtaining what? We are obtaining a v, right? We understand that a v is actually equal to ds over dt. So which means that we can do, this question actually requests us to do a derivative of ds over dt, a ds over dt. Okay, because we need to find out the velocity, because velocity is known, which is 0. So that's why we need to find out the v. Okay, so the v is ds dt. So now we start to do our derivative differentiation. So differentiation for this question is easy one, okay, which we have a constant multiple where we have 160 here. So 160 differentiate 160t, so the 160 is a constant multiple, drag to the left hand side. T itself differentiate, we understand it's et to the power of 1, use the power rule. Power bring to the front, power minus 1, right? Okay, so power bring to the front and power minus 1, so become 1 minus 1 become power 0 lah. Then follows with the second one, again a minus 16. So this minus 16 again is a constant multiple. Okay, we drag to the left hand side here and we try to differentiate the t squared. T squared differentiate the power bring to the front, 2 bring to the front, and power minus 1. The power is 2, so minus 1 now is power 1. So that's why from here we can obtain our differentiation, which this is our v. We understand that ds over dt is our v. V is equal to 160 times t power 0 is still this one is still a 1, yeah, so it's a 160 minus, okay, 16 times 2, we got 32, so 32t, yeah. So v is equal to 160 minus the 32t, so this is what we have, okay. And then you see, since we got the information of v is equal to 0, then now we can just substitute the v is equal to 0. This v can substitute with a 0. Then we come up with this 160 minus our 32t. And we try to rearrange it, okay. We put 32 at the left hand side, okay, bring it to the left hand side for 32 t, and is equal to 160, right? Okay, and then what is the t? So this 32 bring over to divide 160, yeah? 160 divided by the 32, then we have the answers, which is equal to a 5. So your t is equal to 5. And if we observe the question itself, the time is measured in a, if we look at the question itself, is measured in the seconds, right? Okay, so this 5 means 5 seconds, okay? So 5 seconds, but we are not answering the question yet because the question asks how high. So we understand that at this level right here, at this level, the time is actually a 5 seconds, okay, a 5 seconds. So if we want to find out the position or displacement, how high the rock is goes, so actually we can use the equation from here, from the est, because t is already known as 5, so we want to find out the est, okay, so which we just need to substitute the t with 5 for the est function or the s equation right here, okay, and we substitute the t with 5, yeah? So 160 t substitute with 5 and the t substitute with 5, yeah, and then we have here 160 times 5 and then minus 16 times with 5 squared, yeah, so you can use your calculator and the answer would be a 400, okay, 400. So this 400, if you refer back, s is the displacement, means that the traveling distance, okay, like how many is it in the measurement unit, we refer back. So in this question they are using feet, right? They're using feet, so you see everything is in feet, so we write our answers as feet, so it's a 400 feet. So the answer for A is 400 feet, is 400 feet, okay. So the rock will travel up, okay, meaning that this displacement, okay, or the distance right here, I would say that is a 400 feet. Okay, so that's for question A.